we have the graph of f of x, which is equals to log x base 4/3. So this graph is drawn below. We have a point, which is point B, which is a point on the graph with the coordinates 16/9 and p. So this is a point on the graph. Now the question is asking us for which values of x is log x base 4/3 less than or equal to a 0. So they're asking us what are the values of x where this log graph is a negative. Remember, less than 0 means negative. So for which values of x is this log graph a negative, or where it's equal to a 0? We know that this log graph is equals to a 0 at this point. We know that anything below this point, it is a what? It is a negative. So essentially what we're looking for these x values from this point until this point, because from this point until this point, that's where it's negative, and at this point, that's where it is indeed a 0. Remember, it will never be, x will never be what? X will never be a 0. So if you substitute 0 there, this is going to be undefined. If you substitute 0 in your calculator in place of x, it's going to be undefined. Why? Because these y-axis is the asymptote. Remember, this graph will not intersect this asymptote. So essentially what we're looking for these x values. So these are the x values that we're essentially looking for, right? So it's very important that we find this point. What is the value of this point? We know that this is the x-axis, and we know that if we're looking for the x-axis, y has to be a 0. So we're going to say, well, we know that we have 4.1. The equation was log x base 4/3. Remember, we're looking for the x intercept. We know that y is a 0. So this is going to be log 4/3 x. Remember, to change this thing, this will remain as a base. So 4/3 will remain as a base. So you're going to say, well, I know that I have 4/3, right, to the exponent 0. Okay, so this is going to give me my x value. And of course, we know anything raised to 0, it's 1. So we know for a fact that this x-intercept here, it's 1. Okay, so we know that the value of this x-intercept is what? Is 1. But remember, we were looking for the x values where this log function is either a 0 or a negative. We know that it's a 0 at this x value of 1. But anything below this x value of 1, it is a negative. So those are the x values that we're looking for. So we're going to say, well, the x values that I'm looking for are the x values that are less than or equal to 1. But remember, those x values have to be greater than a 0. Why? Because we can't intersect this y-axis, because this y-axis is our what? Is our vertical asymptote. So this will be the answer for 4.1. Now 4.2, very, very important. What are they asking? They're asking us to determine the value of p without using the calculator. So they're looking for the values of p without using the calculator. We know that our equation for the graph is log base 4/3 x, right? So we're going to substitute these coordinates of b. We know that the coordinates of b is 16/9 and what? And p. So we know that our y coordinate is p. So we're going to say, well, this is p, which is equals to log base 4/3. What is the value of x? What is x? We know x is 16/9. So this is going to be 16/9. Now at this point, remember, we're looking for p. You can press your calculator. You can just take this thing and punch it inside your calculator. But remember, they said we mustn't use the calculator. So what you would want to do, we know that if we press our calculator here, it's going to give you an answer of what? Of 2. But remember, we mustn't use the calculator. So instead of just pressing this thing inside our calculator and getting an answer of 2, we're going to solve this value to arrive at this answer of what? Of 2. So essentially what we're going to do, we're going to say, right, we know that this is the base, right? So we're going to change this thing to its exponential form. We know that this is the base, right? So the base, remember, it remains as the base. So this is going to be 4/3, right? And remember, you're going to raise it to what? To p. So this is going to be 4/3 to the power p, right? Which is equals to 16/9. Remember, whatever that is the base in the log will still remain as the base. Whatever that is alone will be the exponent. Right, now I can write this 16 over 9 as 4/3 squared. So we know that we have 4 over 3 to the power p, right? So we know that 16, one way in which I can write this 16 is by writing it as 4 squared, right? And one way in which I can write this 9, I can write it as what? As 3 squared, right? So essentially I will have 4 over 3 to the exponent p, which is equal to, so I can see that the numerator is raised to an exponent, which is 2. The denominator is raised to an exponent, which is 2. So I can just write this thing as 4 over 3 all raised to 2. Remember, I used this law of exponent. If you have a to the power n and b to the power n, you can just write this thing as a over b all raised to what? All raised to n. So that's essentially what I did here. I had 4 to the power 2. I had 3 to the power 2. So I raise these 4/3 all to the exponent what? All to the exponent a 2. Now I can see that the bases are the same. I can just drop down those bases. We see that now the value of p is 2, which is indeed the same answer that you would get if you just press your calculator right away. But remember, they said we mustn't use the calculator, so it means that now these steps are going to be very important. Instead of just writing this thing, leaving it here and pressing your calculator, you have to continue and show this working. Very, very important. The answer of p, it's what? It's 2. Right, now a straightforward question. What they're asking us is to write the inverse of f. Remember, what do we have as f? We have y, which is equals to log x base 4/3, right? So this is what we have as our graph of f, right? So we need the inverse of this. Remember, the first step that is very important when you're looking for an inverse, what do? You interchange x and what? X and y. So this is going to be log y base 4/3. So this is what I'm going to have. I just interchanged x and what? X and y. And remember, you then make what? You then make y the subject of the formula. So this is going to be, remember, this is the base, right? This is the base of this log. Remember, the base will remain as a base. So this is going to be 4/3, right? Whatever that is alone is the exponent. So it's x, which is equals to y. So this is my what? This is my inverse of what? Of f of x, right? Now we are looking at 4.4. Now they are asking us to determine the range of the inverse. Remember, when you're looking at an inverse and the original function, remember, whatever that was the domain here, it's going to be the range on your inverse. Whatever that was the range, it's going to be your domain. We can see that the domain here, it's x, which is greater than what? X is greater than a 0. Remember, because we have this vertical asymptote. So the range is going to be that domain. So the range of the inverse, it's the domain of the original function. So this is going to be the range, which is what? Which is y, which is greater than what? Which is greater than a 0. Now, an interesting one, we have this function, right? So this is the function that we have, right? So this function is obtained by applying two reflections on f. So we're going to take this f, this graph of f, and we're going to apply two reflections. Now they're asking us to write down the coordinates of b prime prime, which is the image of b on the graph of what? On h. So essentially what we're saying is that we know that we have the coordinates of b, right, which is 16 over 2 and 9. So these are the coordinates of b, and they are on this graph. So essentially what they're saying is that we're going to take this graph, right, and we're going to apply two reflections on this graph of f, right? So they're asking us to find the coordinates that are going to be on this graph, which we will get after applying two reflections. So this graph, will obtain this graph after applying two reflections on this graph. So remember, each time when we reflect this graph, even these coordinates are going to do what? Are going to change, right? So let's see. So essentially what we're going to say, well, we know that after the first reflection, remember what we had? We had y, which is equals to log x base 4/3. So this was our original function of what? Of f, right? And the coordinate of b in this case was what? Was 16 over 9 and what? And 2. So we're going to take this graph and we're going to reflect it over the line y equals to x, right? Remember, when you reflect something over the line y equals to x, you are basically finding the what? The inverse of that graph. So we're going to take this graph and we're going to find the inverse. Remember, already we know what is the inverse of the graph, right? we know that the inverse of the graph is this, right? So it's y, which is equals to 4 over 3x. So after the first reflection, this is what we have, right? So this is after reflecting over what? Over the line y equals to x. Now that this is the inverse after the first reflection, it's still not this, right? So it's still b prime. It's the coordinates of b after the first reflection over the what? The line y equals to x. So those coordinates will be what? Will be 2 and 16 over 9. Remember, when you find the inverse, the coordinates are going to swap. So after the first reflection, the reflection over the line y equals to x, this is the graph that I have. And that point B, after the first reflection, it's going to have the coordinates 2 and what? And 16. Remember, when you find the inverse, you just swap the coordinates. So these are the coordinates that I'm going to get. So these are the coordinates after the first reflection, the reflection over the what? The line y equals to x. Now, because I'm still not having this, so it means I must apply the second reflection. Remember, we get this thing after applying 2 reflections on this on this graph. So I've applied the first reflection on this graph. I've got this graph, right? It means I must take what? I must take this graph and reflect it again. So I'm going to say, well, then I'm going to apply now my second reflection. Okay, my second reflection. Now I'm going to reflect over the what? The y axis. Remember, if you reflect something over the y axis, you're basically making x to be a negative, x to be negative. So I'm going to have y, which is equals to 4/3 to the exponent negative x. Right, so if we work this thing out, we know that we are going to have y, which is equals to 4 to the exponent negative x over 3 to the exponent negative x. And remember, this is going to be y, which is equals to, if you want to make this exponent positive, you just put it in the denominator. If you want to make this 4 a positive, you put it in the denominator. So we're basically going to swap. So we're going to have 3 over 4. So it's 3 over 4. And remember, all of them are having the exponent x. Remember, the numerator is raised to the exponent x, the denominator is raised to the exponent x. So it means I can write this thing as y, which is equals to 3 over 4x. Remember, I used this rule. If you have a to the power n and you have b to the power n, this can be written as a over b all to the power n. So this is essentially what I did here. So this is the reflection over the what? Over the y-axis. Remember, I made x to be what? To be a negative. So my new coordinates after reflecting for the second time now, they are going to be, remember, you made x to be what? To be a negative. So it's going to be this point, but the x is going to be a negative. So the coordinates that I'm going to have is negative 2 and 16 over 9.